All right.
Okie
So
dokie.
What were you saying?
did you guys get 625 for number 5?
Yeah.
I think it's
Yeah.
the
You-
almost infinite.
You
I
got the
think
almost
that's
infinite.
the proper. Yeah, that's the proper answer.
I just did the cube root of 125 to the fourth, and that equals 625. So
Nice. Very nice. Okay. What about for number 6? You guys get 7 and -1.
Yes.
yes.
It took me a little. I was like, how do I do these again? And then I think I watched a YouTube video.
Always good. Khan Academy. He always
Yeah,
repeats
Connor.
everything.
Oh
He's
yeah.
right. It's okay.
I hate when it's not what's his name. Whenever it's someone different than the main guy, I don't like watching them.
They
I
have
know,
different
right?
Like, you're not as good as him. I don't know. It's like
Or like when they have like a accent that's hard to understand, you're like, no.
ooh, I never heard that one before.
Yeah.
I just want Saul and that's it.
I think just the important thing to remember with absolute value functions is that there are going to be twice as many roots as there are. It's within the absolute value bar, so there are going to be 2 possibilities.
Right. Yeah.
Yeah. So I guess we already talked about the other ones off air.
Yeah. Kind of. I mean, I still don't know what to do for number. I guess it's the where it's like 6x to the 5th equals -24x to the 3rd, and the one after that,
Okay,
I don't know how to do those. You guys know how to do those?
Well, first I would add 24.
Yeah, I'll add that over to the left side.
Yeah, like equal to 0.
When you do synthetic division on it,
Uh,
like I know there's only 2 numbers, but one's a 3 and one's a 5, which would make the other values zeros.
Yeah.
yeah, I tried doing that and I didn't have much luck. But oh, you know what? I only did synthetic division with 5, 0, and I'm sorry, 6, 0, and 24. I need to have 2 more in there at least.
Yeah. Well, and on one of the homework assignments, it had you do synthetic division and then plug in the answers for that back into the synthetic division and find it again.
Yeah, I remember that one.
So you started out and you did 0 first, right? Is that what you said?
I think it'd be 6 because we got 5. Then we have an x to the 5th, but we don't have an x to the 4th. I think it'd be 6, 0, and then 24.
I'm just gonna plug this into my math sheet.
So x to the 4th, x to the 2nd, or I guess x squared, and x, all of those aren't there, so they're going to be 0, right? With the multiplicity of 3, because there are 3 different options like that.
Oh, so if there's zeros, that mean we just know that they're...
I think so, but don't quote me on that.
Let's see. Oh yeah, you're right. Yeah, that's one of the correct answers.
Yeah. And then what do we do for the other one? I guess we could factor out an x to the 3rd.
Yeah, I tried that. We like a quadratic equation.
Yeah. We could even factor out a 6x to the 3rd, I guess.
Oh, you're right.
So then that would leave us with x squared plus 4. Right?
Yep. Yeah, so x squared plus 6, yeah.
So through synthetic division, I got 0 is an answer.
Yeah, with a multiplicity of 3. Because if we have 6x to the third factored out, that means that 3 of the x's equals 0.
Yeah.
Then since this is x squared plus 4, we should use the quadratic formula because it's not going to factor or anything.
Right. So we just plug. So we're just gonna have. So we're only gonna be plugging in the x squared and the 4 values, right? And then a 0 for.
Yeah.
Okay.
So it's gonna be like -0 plus or minus.
So x is gonna equal. Yeah.
-0.
-0. Isn't that the most beautiful thing you've ever heard? It's almost like the almost infinite.
Yeah.
The number. Okay.
No, but it's funny because that's what my chart comes up with is the -0, even though it's still just 0. It still says -0.
So 4 times 4 is 16. So it's the square root of -16. So that's going to be what, 4i over 4 plus or minus 4i over 4, which is equal to plus or minus 2i.
Wait, you said over 4?
Yeah, so when you're doing it, if you look here, I can't see where I am. Okay, so you have to do 2. Oh, wait. Over 2, I mean. Sorry.
Over 2. Okay, cool. Sweet. Okay.
Yeah, my bad. I was thinking 2 in my brain, and I used 2, but then I didn't. Yeah.
So it's going to be I. So we're taking a 4 out with the I as well. That's what you're saying, right? 4.
Yeah, because the square root of 16 is 4.
Oh, right. Yeah. Okay, there we go.
Where'd you get the imaginary number?
Because it's the square root of a negative, you have to take out the square root of -1, which is I.
Okay.
So you basically just put an I in front of the 16, the square root of 16, and take the negative out.
Yep.
Okay, now I got it. Sweet. Okay.
Yep, so there we go. X equals 0 multiplicity of 3 and plus or minus 2i.
Mm-hmm.
Okay, I guess I do understand this. Never mind. We're good.
You were just pretending to be.
I'm just.
Did you guys check the answers?
Yeah.
No, we don't need answers.
Well, okay, so I checked the
Math doesn't need answers.
And that's correct.
They just need equations.
Yeah.
True. Okay.
Or letters. They like letters too.
Letters are beautiful.
Just not in math.
So do we want to go on anything else for the preparation activities?
The problem after that, do you guys know how to do that one? It's the x minus 3 squared times x plus 14 to the 5th.
X minus 3 squared x plus 14 to the 5th equals 0. Okay.
Well, if you put both the factors like to equal to 0, and then move the 14 and the 3 to the other side.
Okay, so yeah, I agree with that. So you're gonna do just x minus 3 squared equals 0. You can just note that since it's already factored, which is what we try to do, it's going to be x equals 3 with a multiplicity of 2.
Oh. That's all it is?
And then, and then the other one is going to be x equals -14 with a multiplicity of 5.
Wow, you guys are amazing. I did not know how to do this. Okay.
Thanks,
I was like,
Connor.
I was trying to unfoil it all and
Factor
stuff.
it all out.
Yeah, I was like, this is not working.
The polynomial.
You're like,
Nope,
what do I do to foil the
it's like
foil the exponents?
I didn't see anything like this in the resources. This sucks. That's all I had.
So, are we clear with everything then?
Yeah.
We want to do some more.
So let's go to the extension problems.
Yeah.
I guess so.
Well, let's. What were the discussion?
Has anyone
things?
heard from Matthew?
No.
Not yet. As long as he shows up, I'm fine with giving him full credit.
Yeah, because I mean he showed up to the first one.
Yeah. Thanks, babe.
Yeah. That's my bad.
How dare you?
Yeah.
Sorry.
I am irate.
You're irate. Wow.
Can't you tell?
Yeah, I can. You just seem so upset with me.
That's my favorite thing to see on the phone, people.
Do we want to discuss U substitution?
Oh,
Just
sure, yeah.
acknowledge that
Just acknowledge it.
Yeah.
What are your thoughts on it?
It's pretty handy.
Yeah.
Yeah, I guess I've used it before and it helps keep everything neat and clean. It gets rid of weird fraction stuff that you'd have to deal with. But I don't know. I guess it's not necessary. We can use it in number 1, 2, 3, 4, 5. Number 5 of our extension problems if we want to.
Sure, yeah, I'm done with that. I honestly don't know. Like in one of the homework I was working on, I had to substitute you, and I honestly didn't know how to do it without you. Just that it was just so. I don't know that like another problem I knew what to do.
But without the letter G.
Yeah, exactly.
I didn't know how to do it without you.
I didn't know.
That's funny. Okay.
Susan, none of us know how to do it without you.
Oh, thanks, Jaden. Just kidding. You guys would do fine without me. So let's get started with extension problem 1. A.
So I added 12 to the other side.
Yeah, I like that.
So then I can do synthetic division.
I agree with that.
All right, 16.
What are you going to synthetically divide it by?
So we can figure out. Looks like we'll have our options will be 12 over 1. So all the factors of 12 over 1.
All the factors of 12.
Yeah.
See, right? I just set a goal seek on my sheet and hit enter, and it will change all of the information for me.
Can you
and
use
go
that
through all the possibilities? I don't know.
I would think probably not, because she says no notes, no la-di-da, no la-di-da.
Yeah. But to do it,
I don't know. Other than I was the one that did all the calculations for it, to make the sheet. So I don't know.
I guess you could shoot her an email about that.
Yeah. Where'd my mouse go? There it is.
As far as doing it without it, we just take the last.
Yeah.
It's 1.
The last number, and then put that over the first number, right? And then we can just we get 1, 2, 3, 4, 6, and 12 over 1 for our possibilities.
That's a great idea. We should start out by using 1.
I think that's inspired.
Yeah.
Let's try.
I don't know where that came from.
7, 16.
Now, is this one where you'd plug it back in and resynthetically divide, get just 2 factors, or is this where you do the weird factoring with the x to the third, or?
We could do that.
You do either.
It's not actually that. It's not super weird. So you just do x to the third minus 3x squared plus 4x minus 12, and then you group it.
Yeah, and then factor it.
And then,
Right.
yeah, then you would factor out an x squared, and then you're going to have x minus 3 on the inside. And then you factor out a plus 4, and then you have x minus 3. And then you have the factors x squared plus 4 and x minus 3. And then for x squared plus 4, we already did that on one of the problems earlier, remember? And the factors of that are plus or minus 2i. And then the other factor would be 3.
Holy cow.
So then, you see what I'm doing here? Or am I just speaking?
No, I see it. You're just going super fast.
Okay.
I'm at that part where we're still doing synthetic division by 1. No, I'm just kidding. I'm not really that far behind. I'm just kidding. I'm not that far. Like, okay, this guy's an idiot.
No, it's okay. So do the grouping. 2 terms, 2 terms.
Yeah. So we'll get x squared plus 4 as 1, and then we'll get x minus 3 as the other. And then we can just factor the x squared plus 4.
Yeah, which we already did earlier. That's why. Do you remember that in the?
Oh, we did?
In the preparation problems, one of our things was x squared plus 4. That's why I already knew that it was plus or minus 2i.
Oh, okay.
Yeah.
So you can do synthetic division and it'll get you the same answer.
Yeah.
I wasn't sure, so I tried it.
Tell us more about this synthetic division that you do so quickly.
I just usually try to factor if I can, because I don't have an Excel sheet. Well, I guess I do.
I sent it to you.
I know, because you emailed it to me, but yeah, just I never have before in my life, so I factor when I can, so that I don't have to try plugging in terms when they're not certain. So we got all 4 of our factors plus or minus 2i, 3, and 1.
Plus or minus 2i.
Yeah, plus or minus 2i.
Oh, could you just set that to 0 then? Okay, yeah, that makes sense. Yeah.
Yep. Okay. Are we ready to move on? Any questions?
Wait, you say plus or minus 2i?
Yeah.
So minus 2i. I in there. Oh, because it's negative 4. Okay, yeah. I'm sorry. Okay, cool. Got it.
Alrighty. So the next one is x to the 5th plus 3x to the 3rd plus 2x equals 0. Okay, do we want to start with synthetic division?
Obviously.
Obviously.
I wonder what number we should start with.
Or do you want to factor out an x first?
Yeah, I wonder what number we should start with.
Let's factor out an x and get that.
First, and everything's down 1. 3x squared plus 2.
And then we already have a root.
Oh, and then, since it's x to the 4th and x squared, you can just treat it like it's x to the 4th like it's x squared, and x squared like it's x to the 1st. So you could factor that if you want. And then it'd be x squared plus 2 and x squared plus 1. And then, so that gives us x squared plus 2 is going to be plus or minus I. And then x squared plus 1. Wait, 1 second. 1 second.
Synthetic division doesn't work.
Yeah, that's why I'm factoring.
I know this because it just went through every number.
Okay, that's because all of them are going to be... Does synthetic division work when you have imaginary numbers?
I don't think so.
I don't think so either. So, yeah, that's why we can factor it and pretend that... Okay, so... Let me start over. I'll just show you what I did. So... You see that number 2 right there?
Yeah.
Oh no, where did Connor go?
I don't know.
Connor, come back.
Connor, come back.
Okay, so you know what I'm doing there?
Kinda.
So whenever the highest x, the second x, is twice as much as the third, so it's going to be 1, 2, and 4, then you can just treat it like it's a normal quadratic and factor it like that.
Wait a second. Wasn't Connor the host?
Oh, yeah. Connor?
It says we're still live.
Yeah.
Let me...
Retext him. He decided he was done with math for today, I guess.
I guess. He just disappeared. His Wi-Fi must have stopped wanting to, Wi-Fi.
His Wi-Fi doesn't want a Wi-Fi. Huh. Connor, where did you go? Okay. I guess we can finish this while we're waiting for him.
I did not want to get out of bed at 9.
Yeah.
But I did.
Sorry about that. Sorry about that, Jaden.
I was like, I haven't heard anything from them yet this morning. Maybe I'll just go back to sleep.
Yeah.
And then Connor messaged me and I was like, dang it.
So I got plus or minus I. Have you been factoring it?
Yeah.
Square root of 2.
Yeah, plus or minus I with the square root of 2.
Yeah, for the first x squared plus 2.
Yeah.
And then for the next one, plus or minus I.
Yeah.
Sweet.
So that would mean there's one more solution?
No, because we have 0 plus or minus I squared root of 2.
Okay, yeah.
We
I forgot about 0.
Yeah. Sweetness. He said
Connor is trying to log back on.
Yeah.
Yep, his Wi-Fi decided to stop being Wi-Fi.
Oh no. He said he has to end the call and call us again.
Oh no.
Do you play the piano?
No, my mom does.
Oh, sweet.
But, yeah. Who are all the pictures on your wall?
No, it's all John Wayne.
Oh. Nice.
I don't really like him, but I found it. Well, I don't dislike him. I just found this calendar once, and I needed something for my wall. It had a bunch of pictures of it.
So he was John Wayne.
So John Wayne decorates my wall now.
Nice. Are you up at BYUI?
Yeah, I am. I'm on campus housing.
I didn't know they had any more on campus.
Well,